morning. I have received some questions from Maya, Melissa, and Jay, and I'm going to answer them. Thank you for your questions, and please keep asking me questions. I am very happy to answer them. Okay. So we are going to do questions from page 256. The first question asked was 2a. Then we are going to do 2d and 2e, and then 5c. Those are the questions that I have been asked to answer them. So 2a. Differentiate y equal 2 sine x cosine x. So this is the function, and we want to find the derivative of this function. So I can leave the 2 outside and then multiply it with the derivative of sine x cosine x, because 2 is constant, so I can say 2 times the derivative would be the answer. That's fine. Or I can consider this the first function and this is the second. It doesn't make a difference. So I will do it this way. So now we are going to find the derivative of sine x cosine x. As you see, those are 2 functions multiplied. So we have to use product rule. Product rule says the first function times the derivative of the second. Derivative of cosine x is negative sine x, plus the second times the derivative of the first, which is cosine x. So we can write this as 2 negative sine squared x plus cosine squared x, or we can write it as 2 cosine squared x minus sine squared x, and both of them are okay. So this is number 2a, product rule. Okay, so 2a is done. I'm done with this. 2d. 2d says y equal sine x over 1 plus cosine x, and we need to find the derivative of this. So to find the derivative of this is a quotient, as you see, so we have to use quotient rule. So y prime or dy by dx will be log squared low d high, low d high. The derivative of the high is cosine x, minus, and always I like after the minus to open bracket, high d low. The derivative of the low, derivative of 1 is 0, derivative of cosine x is negative sine x, so this will be negative sine x. Now y prime will equal, let us try to expand this. I can write this as cosine x. I will distribute cosine x over everything. Cosine x, and this is cosine squared x. This is minus and minus, so it will be plus sine squared x over 1 plus cosine x squared. We all know the famous trig identity, sine squared x plus cosine squared x equals 1. So it doesn't matter if sine squared first or cosine squared first. So it is cosine squared plus sine squared, that's 1. So cosine x plus this is equal to 1 over 1 plus cosine x squared. this is the same as 1 plus cosine x. It doesn't make any difference. They are the same. Cosine x plus 1 is the same as 1 plus cosine x. As you see, this and this can cancel out and leave 1 on the top. So the final answer in a simplest form, 1 plus cosine x to the power of 1, and that's it. Okay, so I just applied quotient rule, and maybe the only trick is if you remember the trig identities. By the way, I will post all the trig identities in SB. Okay, so this is the 2D. Now 2E. 2E says y equal e to the power of x times cosine x plus sine x. So if we want to find the derivative of this, these are two functions multiplied together, so we are going to use product rule. So first, time derivative of the second. Derivative of cosine is negative sine. Derivative of sine is cosine. Plus the second. Second is cosine x plus sine x. Times the derivative of the first. Derivative of e to the power of x is itself e to the power of x. Now we can factor e to the power of x out. So e to the power of x out. That will leave negative sine x plus cosine x plus cosine x plus sine x. I just took this out, so this becomes negative sine x cosine x plus. Everybody understand this step? I hope so. Sine x and negative sine x and sine x are 0, so y prime will equal e to the power of x times cosine x plus cosine x is 2 cosine x. So this is 2 cosine x times e to the power of x, and this is the final answer. Okay, this is number 2E. Alright, what is left is 5C. C says h of x equal sine x, sine 2x, sine 3x. And we need to find h prime of x. So those are three functions multiplied together. So it is very clear that I'm going to use product rule. So I will consider this as the first function, and this is the second. So h prime will be product rule first times d second plus second times d first. Okay, you can do that, or you can consider these two the first and this is the second. It doesn't make any difference, but this is the idea. The three functions, I'm going to divide them as the first one is the first and the second and the third are the second. Okay, or I can do the first and second as the first and the third one is the second. It doesn't make a difference. So first times derivative of the second. So this is the first, I will write it as it is. Derivative of the second. I want to find the derivative of the second function. But the second function is product of two functions. function. So when I am coming to this, the second, I will use product rule to find the derivative of this. So now this is the first and this is the second. First times derivative of the second. Derivative of sine x is cosine 3x is cosine 3x times the derivative of f of x, which is 3, plus the second, which is sine 3x, times derivative of the first. Derivative of sine 2x is cosine 2x times the derivative of the 2x, which is 2. Okay, so this is the first part. We are done here. First, sine x times the derivative of the second. When we come to the second is two functions multiplied. So I'm going to use product rule to find the derivative of the second. This is the first now, and this is the second. So first times derivative of the second, plus the second times the derivative of the first. Okay? We are not done, we just done the first part. Plus second function, which we said at the beginning that we consider this the second. So second function is sine 2x sine 3x times the derivative of the first. The derivative of the first is cosine x. Okay? Yes. Now I can distribute sine x over up to this bracket. So it will be sine x times 3 sine x sine 2x cosine 3x plus 2 sine x sine 3x cosine 2x plus sine 2x sine 3x cosine x. And this will be the final answer after we multiply sine x with the derivative of this point. Okay, so I hope that you understand this question, and I will stop here. I was planning to talk about the derivative of tan, but I think you need to redo all these questions again, and in tomorrow's video we're going to do the tan function. Okay, have a great day. Bye.